So thank you, everybody, for joining the RVNUG.net user group. We meet the first Thursday of every month, sometimes in person, sometimes in virtual, just like we have today. But every time we bring you great speakers and great topics. And today is no exception. We have Kito Mann presenting today, Modernizing Mission Critical with OpenRewrite and AI. Kito Mann is principal consultant at Virtua Incorporated, specializing in enterprise application architecture, training development, and mentoring with microservices, cloud, web components, Angular, and Jakarta Java EE technologies. He is also the co-host of Stack D podcast and the author of Java Server Faces in Action. Mann has participated in several Java community process expert groups, including CDI, JSF, and Portlets, and an internationally recognized speaker. He is also a Java champion and a Google developer expert in web technologies. He holds a BA in computer science from Johns Hopkins University. We really are appreciating you joining us today and presenting, Kito. Thank you for being here.
My pleasure. So this presentation is called Modernizing the Mission Critical with OpenRewrite and AI. And so what basically I'll be talking about is some of the work that we've done in my little consulting company related to basically modernizing older applications. And we primarily work with Java, but all the different topics I'm talking about, tools and techniques, work regardless of which platform you're using. So Tolga mentioned pretty much everything about me, so not much else to say, other than I am working on a side project called Speaker Tracks, which is a site for frequent speakers. So if you like to speak at conferences, you should check it out. Obviously, Stack D podcast is fun if you like podcasts. That's pretty much it. Okay. So before we begin, I wanted to sort of explain what modernization is, or at least what I mean by it in this particular context. So, and this, of course, is Wikipedia, which is of course the source of all truth before ChatGPT. So, software modernization, also known as legacy modernization or platform modernization, refers to the conversion, rewriting, or porting of a legacy system to modern computer programming languages, architectures, like microservices, software libraries, protocols, or hardware platforms. The legacy transformation aims to retain and extend the value of the legacy investment through migration to new platforms to benefit from the advantage of the new technologies. It's kind of a mouthful. This is basically what I mean. This is something that I've been involved with for the last few years because I've been in the industry for a long time, and I'm familiar with a lot of the older stuff and a lot of the newer stuff, basically. So these things have kind of come along the way. So with that definition in mind, I wanted to get a handle from those in the meeting about how many of you are actually involved in a modernization project or have been involved in one recently. So if you can raise your proverbial hand. Okay, there's one person. Oh, okay, so a few of you, cool. So maybe at the end, I can hear some, or even along the way, I'd love to hear about your experiences as well, because that's always good to know. So, all right, cool. So what I always wonder when I start in one of these engagements, I'm like, okay, so how did we get here, right? What is it that kept us on an older stack of software? And what I've seen are a few different things. One, which is probably my least favorite, is if it ain't broke, don't fix it, right? So basically, you have organizations that have software. It may be a production, like it may even be, as I say, mission critical. But people built new features over time, and they basically, if it's not broken, they don't fix it, right? So time goes on, and next thing they know, they have their tech stack is like 10 years old or 15 years old, and they are having some issues as a result. So I think this is a very common problem. And one that I think can actually be fixed organizationally by taking a good approach. Once you've done the modernization process, then you can actually keep things modern if you integrate that into your process. And we'll talk a little bit about that as well. A much better excuse is maintenance mode, right? So you have an older application which is maybe important, but it's in maintenance mode. Maybe it's being phased out, maybe it's being replaced, or for whatever reason, there's no new features are being added, and it's just running, right? And that situation I kind of understand. So, and I think this is often the case when you have a system where here's a good example. I had one client that needed to upgrade a system, but they had migrated all the lines of business. It was an insurance company. All the lines of business have been migrated except for like 2, which were running on the old technology. So But what happened was the old technology was running on an app server whose maintenance and support had lapsed, which they didn't want to happen. So they wanted support. So we had to upgrade their stuff so that they could run our newer version and get support. And knowing that they were eventually going to replace that newer version with their new platform. So I consider that more in maintenance mode. And in a couple of years, like I think it took them 2 or 3 years after we did the migration, they went ahead and basically got off that whole old tech stack. So that I understand. Maintenance mode makes sense. Another common thing is that the company, it's not that they're thinking if it ain't broke, don't fix it, but really what they're thinking is we are focusing on features and bug fixes, right? So something's broken, they fix that one thing. Or they just have new features they're trying to push out, which is often the case. And there's really no effort being put into like sort of keeping the stack up to date. They're just trying to push out new features. And this makes sense because this keeps clients happy. Having new features, new shiny features. You see this a lot with all of these AI features, which most people don't want. But it's a new feature, right? That also helps you get new customers because you can now slap AI on it or whatever new feature, right? And of course, these things boil down to revenue. So management can see a direct line between what you're doing and actually making money, or perhaps what it is the new features help your company, like if you're a trading company, right? A new feature might help you do more trades or trade more efficiently. So things that affect the bottom line, the company is very happy to help with. And the other thing I see is also, and these things all go hand in hand, like lack of process, right? So you may have people that actually want to do upgrades on different libraries or migrate from one platform to another, or make some incremental upgrades, which is really all that needs to be done in most cases. But there's no process in place. So, there are some people that want to do it, some that don't, and management doesn't really care. So this is what I see as well. The other thing I see is lack of vision. So, sometimes I'll have a client and I'll be like, okay, well, we can help you do this particular modernization process, right? But what is your long-term vision, right? What do you want? What do you see in the next, year, 3 years, 5 years in terms of your architecture? And some people just don't know, right? And if it's a mission-critical system, then you really should be thinking, okay, how is the architecture going to evolve over time, right? As opposed to just worrying about features and bug fixes. So these are some of the things I see. All right, so that's why companies don't update their tech stacks. But what are the actual drivers for modernization? So given that they haven't upgraded everything, what actually forces them to do it, right? And probably the number one reason would be, of course, aging software components. And probably what I've seen in terms of aging software components, the number one thing is security vulnerabilities. So how many people have seen a lot of this come up at work where they're like, hey, we have security vulnerabilities, so now we actually have to do something about X, Y, Z, right? And the way I see it in a couple different scenarios. One is where it's client driven, right? Where the clients actually are like, hey, dude, your software has vulnerabilities, we ran some scans, and you should fix that. And of course, that's a big driver, right? Because if your clients aren't happy, then you can't make money, right? It's also hard to get new clients, right? If everyone knows your software has security issues. And of course, that boils down to revenue. So that's a big one, right? Another one which we've seen is the internal security team, right? So let's say you have a security team in your organization, they do scans on your stuff and they're like, dude, this is ridiculous. Like you have all these vulnerabilities, all your stuff is like 10 years old. So we see that as well. Another one is senior leadership, right? Senior leadership hears about all these hacks and stuff and are like, hey, we don't want to get hacked and, get really bad press and lose lots of money, right? So that's another one. And I don't know about you guys, but I think every 6 months or so, 3 to 6 months, I get a letter from like some healthcare provider or somebody that's like, oh, we had a data breach. We offer you a free year of whatever monitoring service as our way of compensating you for leaking all of your personal and medical data. So any company that where the leadership is actually worried about that, they're much more likely to push on actually upgrading stuff to get rid of security vulnerabilities. Okay. And I did sign up for one of those, by the way. I was like, yeah, it's free, might as well. So also with the aging software components, you can be stuck with older libraries, right? I mean, this is, all these things are related, right? But what we've seen is that sometimes one or more components are preventing upgrades. So what happens here is there's like, dependency X, and you have an upgrade dependency X, but Y and Z depend on it. and you can't upgrade them, and then you kind of get stuck. So this affects scalability, performance, and one of the things that's often overlooked is this affects the developer experience, right? So, if you're stuck on an older version of your framework, and all the new kids are using newer versions, it's kind of not cool, right? And eventually, you start to think, oh, geez, we're stuck on, and I don't know the exact analogy to this, but the .NET framework has been deprecated, right? Just the whole big framework. Am I right about that?
There is a newer version. The 4.8 is still in support because it ships with Windows, and anything that ships with Windows never ever dies, apparently. So,
Okay.
so the latest version of 4.8 is still actually in support because of Windows.
Okay. Well, for us, for the Java community, what happens is Java is now in version 25, right? But there are still organizations that use Java 8, or Java 9 or something, and there's
the new versions of .NET, but some people call it .NET Core. They dropped that moniker back in .NET 5, I think.
Oh, really? Okay.
So it's just called .NET now. But those versions are limited on. We have a LTS versions. I think it's the odd number ones are LTS.
Okay.
Somebody correct me if I'm wrong, but every other release is LTS, and they do go out of support pretty quickly. Those are easier to upgrade though, because you don't have a big system installation often that you have to do. You just ship it with your application. You don't have to worry about, all these other things are going to get affected. But yeah, we .NET, the newer .NETs are deprecated, and they do stop security patching them, and so you do have to keep up to date. My company, we try to be at least within the last 2 releases of the latest version of .NET.
That's exactly how it should be. Yeah, so I've seen similar stuff where and Java has the same sort of deal. I think it's maybe every 3 or 4 releases, but they release every 6 months. So I think it's every year or 2 there's an LTS release. Yeah, but the Java 8 stuff, 8 and 9 is even way before they even started doing that. So the way I look at this is okay, so you're busy getting your features out, but your developers are stuck using something that's so old, they probably want to use some of the new stuff. It's a good way to retain people, right? So yeah, and this actually goes into what you're saying, the whole end of life thing, right? So there's often a big driver, whether it's the core platform or some other framework or server, there's often the whole end of life thing. There's no support. So you kind of have to upgrade. But the fact that there's that particular component is end of life keeps you from upgrading other parts. So we run into this with a component library, sort of like an ASP.NET component library that was deprecated 10 years ago. So it had all these dependencies that people are stuck with. So they can't upgrade anything else basically because they're using this library which is over 10 years old and does not support it or update it anymore. So that we find as well. This is actually another driver, which I don't think people think about as much, but we've actually had a client that needed to do a modernization because they had an outdated look or feel. They basically had been acquired, and the company that bought them out was like, hey, your Apple's really old, and we wanted to look modern and everything, but they didn't want to do a whole rewrite of the front end. So there was a modernization effort that we helped them with for just the user interface part, so that it looked better and more modern. But they didn't rewrite the whole thing. But that did allow them to upgrade all of their dependencies and all that kind of stuff. So that's another sort of interesting possibility. Probably another one of the most common reasons for doing a modernization effort is cloud migration, right? And we've all been through this, right? There's companies, the company has some stuff on-prem, they want to move to the cloud. And of course, to do that, they have to do some refactoring and upgrades and things like that. And I've seen this in so many different organizations, and there's so many different platforms people are on, on-prem, and they really have to rethink how they do things. So cloud migration is probably the biggest driver, I think, after security. All right, so we've talked about what modernization means in this context, and some of the drivers for it, right? So let's start a modernization project. So let's say you just start a new project. The first thing I say is, what is the goal, right? What are you trying to accomplish? Because that's always a good thing to think about when you start a new project. And these are all related to the stuff we just talked about, right? Like upgrading libraries and frameworks. So for on the Java world, you might be upgrading Spring Boot or Spring Framework, which often is used on microservices and basically just a lot of web applications and things. Maybe upgrading the server, maybe upgrading the operating system, all those sorts of things. And also, as I said before, you might be upgrading the look and feel. And if you have an older application, let's say you have a ASP.NET application, you may say, okay, let me move to Angular, Vue, React, or Blazor. I know about that one, or something, which would require actually rewriting that stuff, right? I'm actually talking to someone today who said where they work, they actually had an old ASP application, not ASP.NET, ASP running on Windows Server 2000 on-prem somewhere, because they're looking at cloud migration. So there's definitely a lot of things to talk about. So, if you're talking about migrating that, you really would be talking about, rewriting it, of course. But normally the applications I deal with, they want to keep some of the code. They don't want to throw everything out. So, and often this is something which I find interesting. Like a lot of times people want to modernize stuff, but they don't always want to modernize the architecture. Really what they're interested in is more of getting past the security vulnerabilities, upgrading all the dependencies, right? And maybe upgrading to a newer version of everything they can upgrade to. But a lot of times they don't really seem to want to modernize the architecture that much. And I think that needs to be a big part of the discussion as well. And if that's the case, then you may be taking a monolith and going to microservices, or having a monolith and looking at just making a modular monolith. So you have different domains that are developed that you can kind of reason about separately. And if you need to, you can split them off into different services. I like that approach. I've never bought into the whole microservice thing. It was always more about okay, understanding that you can deploy a small unit is awesome. So just use that when you need to, not all the time. So I've always talked about right-size services. That's always been my thing. But modular monolith helps you kind of move to that if you need to. And this is something we see a lot in, removing deprecated and unnecessary layers. And I find that it's helpful when you know that you're going to be touching lots of code to try and do as much of this as you can. And some organizations are willing to do it, some aren't. But this has been helpful in situations where you're not going to rewrite everything, but you have between the time a user clicks on a button and the time something happens, 4 or 5 different layers, and really should be 2. It's a good time to go ahead and do that if you can. So that's another thing you can do as well. Another area which we see is packaging. So you were talking about before, Tola, how with a more recent .NET application, you can just deploy the whole unit, right, and not worry about the Windows version of the .NET runtime. To me, that's sort of a packaging issue. Like some of our clients, even though everybody wants to do everything in the cloud, we have clients that have stuff on-prem. Maybe it's air-gapped or something. There's a reason why it's on-prem. And in that situation, they've written installers to do all these things, but sometimes there are ways that you can package things that are more efficient, right? A lot of them I'm like, well, why don't you just use Docker or something? But there's things you can look at along those lines as well. And
for us, the biggest challenge and the biggest benefit you get from the way .NET Core or newer .NETs are packaged, and you can actually do system level installations, I think, but we never do that. It's always packaged. The whole application goes in its own directory with the framework included.
Right.
The reason is you can upgrade one without touching everything else. Exactly. Because if you have to upgrade everything at once, or one upgrade impacts all your other products, it becomes a barrier for upgrading, and it's just too risky. So you don't do it.
Yeah. So this, if I was working with an organization that was that wasn't doing that, I'd be like, hey, you should do that, right? Package it all together as one big package, I guess is what you could say. So yeah, definitely. Okay, so the other thing I look at is what are the constraints. So so you figure out what you want to do, right? And then what are the barriers or constraints that are involved? Number one is, of course, time, right? This is, and these projects always start later than they're supposed to, and usually take more time than they're allotted, right? So time is always a big constraint. So you may have decided you wanted to re-architect the whole thing, but there's not enough time, so you don't do it. So things like that. Risk is another thing. So if you're time pressured, you actually have to do a release, then there's risk involved, and you want to make sure that you will minimize that risk, right? So you may be more conservative in terms of what things you change. You're not gonna, I don't know, rewrite the database layer if you have to go into production in a couple months, right? Probably not a good idea. unless you've got a lot of safeguards in place, like lots of automated tests and things like that. And then of course there's resources, right? So if you want to do stuff but you don't have the resources, you can't do it. So those are all the things to keep in mind. And those resources, obviously there's development, right? But one of the things that people often forget is QA, right? So you've got like, people that are gutting parts of your application basically, or migrating lots of stuff and making lots of wholesale changes. In those scenarios, you really want to ensure you have QA. So this is something I say at the beginning of every engagement, largely because when one of our earlier engagements doing this kind of work, we didn't really say anything about QA. And then we realized that, we were making all these changes and we were finding, and there was no one verifying our work, right? And so I was doing some QA, but I don't even know the business. So I was just basically doing some basic QA to make sure nothing blew up. But that was a big issue. So from now on, we're pretty much like, okay, we want to know what QA we have in place. And if there isn't any, then,
here's the forecast for tomorrow.
Sorry.
Look for snowy
Alexa, stop.
with a high.
Thank you. Hey, more snow. Yay. So we want to make sure there's some QA involved. And if there's not, then everyone needs to know what impact that's going to have on the project, right? And we can always bring in QA people, but then they have to get up to speed on the business, which usually is not really very efficient. So another area is design. And people don't think about this much either. Like if you're affecting the user interface or the way the user interacts with your system, you need to think about whether a design is going to be impacted. And if they are, you need to have them involved up front. And we ran into this actually because we work full stack, but we deal with a lot of front end stuff as well. And we said, okay, well, we're gonna migrate the front end or modernize the front end of your application. But in order to make this like more bang for the buck, since we're touching every page, if you want, we can apply your new look and feel to the entire application because they had a new look and feel. The pages all looked really old, right? So they said they agreed to that, but they did not adequately give us design resources. So what happened was design became a bottleneck because we'd be like, well, what is this supposed to look like? And then like we never found out. So you just have to make sure anyone that's involved in the project actually has time available. And then when it comes to thinking about what we're talking about doing architecture, modernization, or just upgrading libraries, etc. So that's basically it. Are you doing upgrades only, or are you doing upgrades and improvements? So improvements could be architecture, could just be refactoring, things like that. Okay, and often we end up in situations where they don't care about improvements. They just want the modernization work. They want it to work like it did before. We even have to reproduce old bugs sometimes, which I don't like doing, but but you just need to make sure you're clear on what that is, because often, it's really easy for me when I come in and work on something to want to refactor it and make it better, right? But if you do that on if it's a big project, that can really impact the speed, and that may not be what you want to do, and also could increase the risk. So that's another important thing to keep in mind. The other thing is, what is the approach, right? So there's two approaches and of course there's probably an area in the middle, but there's two that we consider. One is what we call the Big Bang approach. You can imagine there's a cool graphic here. There will be eventually. So the Big Bang is where you basically say, let me get rid of that. Big Bang is where you basically say, all right, so we're basically going to create a new branch, and then we're just going to migrate or modernize all your stuff, right? This, of course, is possible in scenarios like on an application level, right? If you've got if you're modernizing 20 applications, then Big Bang is really, you probably have to drill down into each application individually and decide the best way to handle it, right? So on an application level, you can say, all right, I am going to create a new branch, and we're just going to modernize everything. It's going to take X number of months, and then maybe every now and then we'll merge stuff back in from the main branch, or develop whatever it needs to be. And there are cases where this is really the only thing you can do. And so if your primary libraries are being upgraded, you kind of have to do this because otherwise nothing's going to work, right? But you can do things where you upgrade parts of it using Big Bang, and then you use an incremental approach for other parts, which I'll talk about. So Big Bang is actually, in a lot of ways, one of the easiest things to do. You can develop quickly. You have fewer constraints to worry about, less management overhead, because you can basically say, what's up. You can, your stories, if you're managing things that way, can be more about like big swaths of functionality, upgrade this part or upgrade all the dependencies for this, or, you can be more fine-grained in terms of how you handle things. So you don't really have to manage it as closely. And if you are affecting the user interface, then the look and feel will be consistent throughout because you can just basically do work on it all at once, right? Now, the drawback to this approach is that QA has to do regression testing on the entire app, which can be time consuming. Although you can iteratively, have them do QA. And we've done this, we've been on projects where they do this too, where even though like you're doing Big Bang, QA is involved earlier as opposed to at the end. So they're involved on testing parts of it. Like let's say you just upgraded or modernized the admin module, right? So maybe QA tests the admin module, but knows not to test anything else, So you can have QA involved earlier if possible. But they are going to have to do regression testing on the entire app when it's done. Also, it's possible that you have unused parts that are converted. So if you're kind of converting everything, there may be code that like isn't even being used that you've spent the effort converting because you didn't check to see if it was being used. So it's not necessarily a bad thing, but it's a side effect. And it's a little more risky because you're kind of doing a whole bunch of work at once and hoping it works, unless you involve QA earlier, in which case you can get some earlier feedback, which is of course helpful. Whether or not you can involve QA earlier is going to depend very much on how you're doing things, right? I was on one project where we weren't doing the core work. The client was, but they sort of were doing everything in one branch. So stuff would get fixed and break, and they had QA involved, which is great, but it's a little bit chaotic because like QA would test something one day and then it wouldn't work the next day and things like that. So, and a lot of that had to do with the fact they didn't have any automated tests, right? Because that would have at least caught some of that stuff. So Big Bang is easier to manage in a lot of ways, but you can also do the incremental approach. And this is where you basically say, all right, and this only works in some scenarios, right? But you say, okay, I'm going to modernize parts of the application at a time, right? And you can do this on like a page-by-page basis if it's a user interface, or you can do it on a module-by-module basis, something like that. And the pro here is that you can really have ensure that the application is working all the time, right? Because anytime any particular story is complete or feature has been modernized, you can test it, right? You test it and then put it in the main branch and it goes into production, or at least maybe not into production, but goes as a completed feature, right? So which is nice. So you have a lot more confidence that it's working along the process, right? So it's less risky. Whoops. Sorry about that. Can I switch? Okay, here we are. Okay. And this is what I find interesting. So depending on how you manage this, you can find a lot of unused features and artifacts. So on one project, the way they were doing this is they basically had a story for basically every single page or set of functionality, basically. So you may have like a page that can do 20 different things and has a whole bunch of pop-ups, right? So we were migrating one of these at a time. So we ended up with dozens and dozens of stories, right? But each time we would complete the story, it would get reviewed, code review, and then it would get go through a whole QA process. So it was a very good incremental migration process. A lot of overhead for management, but it was good to manage. But because of this, because they were actually going through and finding each page and that needed to be converted, they found we found all this unused artifacts, all this unused code. We found code paths that no one ever used. So we actually got to remove a lot of code because they had to methodically go through and find out what needed to be migrated. So that was kind of an interesting side effect to see that. So that was a good thing. Of course, the con is that if you're doing this with the UI, the UI is going to be inconsistent because you're modernizing parts, right? So that's an issue. This has a lot more project management overhead because you've got to do QA on every single feature, and you've also got to determine what every single story is. Every single page or feature or module, whatever, needs to be managed individually. So there's a lot more overhead that way. But either way, it can be successful. We've done them both. Okay, so that's the idea of different, which way to do it, Big Bang or incremental. And it also helps to define slices, because slices help you sort of inform the best way to do things. So this allows you to sort of do things in parallel sometimes, and helps you sort of determine dependencies. So my example here is a job example, and I will give you a bad .NET comparison. So I don't know what the Java EE thing would be in .NET land. But you know, rich faces or prime faces could be like, you know, Telerik components to some other component suite or something. And then I think there was an nhibernate, right? So this would be nhibernate to
Entity framework.
yes, thank you. I knew it was something like that. Okay, yes, entity framework, right? And of course, you can upgrade versions of .NET framework, different build tools, and you know, dependencies. And we've actually, believe it or not, we've had a few projects where we had to move from Subversion to Git, which is kind of surprising these days. But yeah, so sometimes you go in and you think your job is, you know, more at the top here, right? You know, just to upgrade some libraries, and you're like, oh wait, they've got an ancient build system. Oh wait, they're using Subversion. You know, so there's all these different layers. So this is why I like to point this out, that it may not just be one thing.
I miss source safe.
Yeah, I remember that.
We haven't used anything but Git for a decade, but we were a source safe shop before we went to. Actually, no, we went to TFS. Then we went to.
Did you guys ever use Star Team before? That was one back in the day, because I used to do most of my Windows stuff was Delphi. It was way back in the Borland days. So there was, I think it was yeah, that was one of the ones out there. So yep. But you know, the more I learn about Git, the more I like it. It's just so ridiculously powerful and flexible, which is good and bad. But, all right, so we've talked about all of those things, but the name of this talk is, you know, modernization with OpenRewrite and AI, right? So where do those come in? So once you've gotten through all of the areas, or you know, the steps of deciding what you're going to do and how, then of course you can pick tools. You know, the way I look at this is I like to start with this slide, right? So can't my AI tool, whether it's Claude Code or Codex or Copilot or whatever, can it just magically migrate stuff for us? And I'm here to tell you no. So if you think this is the case, I'm here to tell you do not do it, because it's just not there yet. Maybe it will be, maybe it won't, but it's not going to magically do it for it.
You made Ron very sad.
I know. So what we found, and of course they're growing and changing all the time. So maybe I'll do this talk in 6 months, and I'll tell you I can press a button and magically it'll do it in 10 minutes. I don't know. But what we've seen is that, number one, since I'm not the person that works at Anthropic or something, I still will review all of my code generated by AI. So I think for most of us that's still the case, unless you've got a really tight feedback loop and process for everything, right? So you still gotta read the code, right? And unless you have a small project, even though they've gotten much better about context, it's unlikely they're gonna understand your entire project if you've got, like, you know, a real enterprise application, right? With, like, you know, millions of lines or hundreds of thousands of lines of code and lots of different artifacts and a messed up project structure and all sorts of things that we see in enterprise applications, right? The other thing is that we've actually find that they sometimes have a hard time with those weird project structures because they're just not used to them, right? Also, the thing about generative AI is that you run it twice and you have different answers, right? So if you're doing a migration project or a modernization project, you probably want to be consistent, right? I would imagine if you're upgrading from library A to library B, you want to do it the same way every time, not different ways at different times. And the biggest issue that we've seen is that it may not do everything correctly, right? So I'll give you an example. We had one client. We did a lot of migration for them with the front end component suites, but then we also helped them with just back end Java Spring stuff, right? And they started that process themselves. I think Cursor, and you know, it did okay. And we basically spent a lot of time fixing bugs and rewriting stuff which was done incorrectly, and things like that. So it's like there are better tools to do this. And especially the stuff that they were doing, there's actually better tools than just using Cursor or, you know, Claude Code or whatever. So the better tool is OpenRewrite. So how many people have heard of OpenRewrite? Anybody? Nobody. Okay. Yes, less popular in the .NET world. But OpenRewrite is a tool for doing code transformation. So it can transform basically code from one state to another. And what it does is it uses something called a lossless syntax tree or semantic tree. Sorry, I always say that. So it's sort of like an AST. This example, this is a Java example, but it should make sense to you. So on the left-hand side here, we have code, right? And basically the LST transforms the code into a tree, right? That basically represents everything. And the reason it's called lossless is because it actually includes comments and spacing and all that kind of stuff. So when it rewrites things, you don't lose all that context, right? So basically what happens is it parses the code, it creates an LST, and then you or other people can actually work with the LST and change it, right? So you can say, well, I want to change the class name to this. I want to change this type to that. I want to change the package name to this. I want to, you can make all these changes, right? And it does this with different languages. You can be Java, XML, C#, JavaScript, etc. And then you can work with it and make changes. Okay. So this is the way OpenRewrite works. And what's nice about this approach is that it's, number one, deterministic, right? You run it 2 times and it does the exact same thing every time, which is nice. And it's composable, so you can actually take smaller pieces and build them together. So, for example, we have a lot of recipes that work with XML. One of the most primitive things to do with XML would be to change the name of an attribute, right? So we have lots of recipes that use that tiny recipe to change an attribute name, but they have a specific goal, which is to change a set of attributes that have some property to some other property. So you can basically build them out of smaller blocks, which is nice. Also, since they're deterministic, they're also auditable, right? So you can run your AI tool, but do you know really what it did? I mean, you can do it. You can do a diff, right? But with OpenRewrite, you can actually know exactly where it went, and what it did exactly, which is nice. Also, OpenRewrite has actually been around for a long time, longer than popular AI tools, longer than all the current chatbots and code tools from Anthropic and OpenAI and stuff. So we like to use this as part of our arsenal. So I will do a demo, and what I'm going to do here is onto new browser window. Okay. And so first we're going to go to openrewrite.org. Okay. All right. So OpenRewrite, it's sponsored by a company called Modern, and it's obviously open source, but they have an enterprise product that'll basically run OpenRewrite on hundreds or thousands of repositories. So from an enterprise product, it's useful. But we can look at different recipes. So we go down to C#. Okay, I wish there were more here, but there are some recipes. All right. So there's okay. This is actually useful. So these are actually different rules, right? Vacuum field for dependency should be static read only, etc. So in addition to doing modernization stuff, you can also use it to enforce rules as well, because it'll just rewrite them, right? So we'll pick an interesting one here. Parameter type should be nullable, right? Very simple here. Tells you how to run it, and you can pass in different values to it. And if we were to go to the actual issue, okay, it's written in Java. Actually, yeah. Well, this isn't very easy to read, but basically, it's, I guess, a rousing recipe is the superclass that it uses. And yeah, that's maybe not the best example there. Try another one here, maybe property metadata analyzer. Okay, so these are not the best examples here. But you can see that basically the idea is that they're going to go and look at parts of the code and do some modifications on it. Now let's see. So it looks like a lot of these are more for analyzation stuff. Yep, avoid unsealed attributes, consider calling. Exceptions should be public. So a lot of these are basic rules that it'll enforce. So if you look at the Microsoft ones, we'll look at exceptions should be public. Oh, nice. All right. But you see there's a rewrite C# project. All right, so this is apparently not the best demo. But but hopefully you can get the ideas. If I will look at look, there's a .NET one. Maybe this.
We can do Java too. I mean, our group doesn't exclusively use .NET, so we have Java users here too.
That makes me feel better. But this actually is useful, I think. So this is more of a common use case. Like CC, that was more enforcing rules, right? These would be more about doing an upgrade. So I run upgrade assistant upgrade. Yeah, I don't know what that is. But all right, so I will show you a Java example. So let's see. And we'll do, actually, let's just do OpenAI. This is something that'll work for everybody, I think. So this is an example of composite recipes. So migrate from API implicit params to parameters. This is just basically a simple name change. Okay, so we'll look at this. And you can also write recipes this way as well, just using YAML. So you see there's this, okay, so this is for Java, but it's for the Swagger implementation in Java. So this is, see, we're changing dependencies, with old names, new names, changing a type this way, changing type this way. And see, each of these are smaller recipes. Like this is change type, right? But this big recipe includes all these other ones. And so these, again, have change dependency, et cetera, et cetera. So this is probably a good example of a combined recipe. So we do this, of course, if you've got like a whole bunch of these that you want to use. So that's a pretty good one there. And I think what we'll do is, so that's sort of the idea of sort of the different types of recipes and composing. If I were to look at there's a lot of ones for Java, of course. So let's see if we did it's kind of basic recipes, like, you know, show this first, replace null with this, different other things for OpenRewrite, etc. I'm going to look at a very simple method here. Let's see. Okay, so add comment to method invocation. It's very simple, right? Okay. So this is a recipe. And basically, the way they work, so you can compose recipes using YAML, right? But if you want to write a recipe from scratch, you basically write Java. And I think they might have other language bindings. I'm not 100% sure in terms of what you have to write the recipe in. The recipes obviously can work with different languages. But you basically say, okay, this is the name of the recipe. It's the options that it supports, the parameters, description, and you have this visitor, and the visitor can get basically can look at methods, it can check preconditions, etc. And you can see this is handle method call, and you see it's creating a new comment, and then putting stuff in the middle, and basically that's it. So it's really simple, right? And this is actually a good example. But obviously you can build up, you can use it inside of any other recipe, right? Which is nice. And you can write your own recipes that are like this, that do specific things for your own code base, right? What you can also do is when you have scenarios where you're upgrading, doing a normal upgrade, you can just use an existing recipe. So for example, that .NET one, you know, if you were upgrading a version of .NET, you could just use that. You know, if you're upgrading from 6 to 7, 8, 9, etc., you could use that. And you see they've got ones for Docker, etc., and all sorts of fun stuff. So and also they have JavaScript as well. You can clean up dependencies, things like that. So add a dependencies, find a dependency, upgrade a dependency, etc. So basically the idea here is that you have deterministic things that you can write, right? And then you can run them on one project, one folder, many projects, depending on what you want to do. And that gives you a lot more flexibility. I will go back to the slides. Okay, so that's great, right? So there's a way to do this deterministically, but I still just want to magically throw my AI at it and have it do the work for me. It's probably not going to happen, but you can combine the two, right? So how many people have heard of tools like Copilot migration, something rather, or one of the other ones I have listed here? So there's one person. Okay, good. Or Amazon Q developer says they have this magical migration tool. IBM probably not something in .NET world, but in the Java world, they have this modernization accelerator. So everybody has, not everybody, but there are some tools that do this stuff. And almost all of them actually use OpenRewrite under the hood. So let's say, like, and this, I think Amazon was the first one to do it. They had this Amazon Q Developer is their little agent coding tool. And as part of it, they had this migration. And it seemed like sort of a separate thing, but it was part of the whole branding, right? And I found out later that that was all with OpenRewrite. And I think that's why they changed the license for OpenRewrite, so that like Amazon, everybody couldn't just take it, because it probably had like an MIT or an Apache license at first. So this is also true for Copilot as well. So what they do is they run a whole bunch of OpenRewrite recipes, and then they will iterate over it using agents to fix the bugs, right? Which is pretty much what we've been doing manually, right? Because we basically have been running OpenRewrite recipes, and then we fix all the bugs. So one thing you can do, you can, number one, try to look at one of these tools that say they do migrations and see if they work. I think a lot of them are kind of young. Actually, from what I've heard, I'm not sure they're ready for like a really big project, but we'll see. But they do use this sort of hybrid approach, right? Where they use agents to do stuff, and they also use OpenRewrite. And to me, that's the winning solution, whether you use a tool to do it like Copilot, or whether you do it yourself. The other thing that you can do is, these are the different tools that I was talking about. Copilot have modernization, Amazon Q, code transformation. The other thing you should consider if you're looking at one of these tools, whether it's these or another one, is what is the role of the vendor, or what is the goal of the vendor? Because oftentimes their goal is usually to get you to use more of their products, right? So Copilot app modernization has a really handy, like, deploy to Azure button, because that's really all they want you to do. Like the whole point of that tool, I'm being cynical, but the whole point is to get you on Azure, right? That's why it's free. And that may be fine, especially if you're using Azure, but if you're using like AWS, you should consider, maybe you should look at the Amazon's one, because it probably has all these special Amazon bindings, right? So just keep that in mind. So what is our approach? So our approach is basically the hybrid here. So we basically start by analyzing the code base, and we provide detailed recommendations. If the client is okay with it, we love to do like a full analysis and write up all these things we think they should do, right? And that can be anything from basically giving them options like we talked about, bang versus not, incremental, which libraries they can upgrade, and other things like packaging and things like that. And also, since we're looking at the code, we usually say, okay, well, you also should probably do this with your code base as well. And then when we start an engagement, we execute custom and open source OpenRewrite recipes. So there's plenty of open source ones that do a lot of basic things, like upgrading versions of Java and things like that. And then, of course, we write custom ones as well for the kind of work that we do. So we do that as well. And one of the things you can do when you write OpenRewrite recipes is there's nothing to say you can't use AI to write the rewrite recipe, right? So you can, I'm sure if you, actually I know that if you say, to Claude Code or whatever, hey, I want to write an OpenRewrite recipe, and you define it well, it can probably write one for you, right? And then you can test it. You can actually write unit tests for them, and they're deterministic, so they actually do the same thing every time. So this to me really is the win. Like if you and the way we use AI is we use it, just strategically, right? And of course, QA is essential. We try to get them involved really in the process. So talking about AI coding systems, use them where they make sense. For dependency management systems, like build stuff, they're great. Like, help me move this thing to that thing or upgrade that library, We've used them for lots of specific things. Ant is this ancient Java build tool, which, I think it was around, I've been in the industry like maybe 25 years or something, and Ant was like early in my career. So Ant has been around for a long time, and we've come across it recently, and they're pretty complicated scripts. Ant is very like, I don't know how to explain it. Like, it's actually XML based, but it's very like loosey-goosey. You can make it do whatever you want. Copy this, move this, copy this, it's that sort of thing. So the scripts we ran across were really complicated, and a lot of the initial conversion work we had Claude Code do, and then we cleaned it up. So it's good for that kind of stuff. It's really good for translating logic. So there was one situation where I had some pretty convoluted logic that was repeated in like 3 or 4 places. And I needed to change the logic for the upgrade we were doing because the new APIs had changed and stuff, right? But I didn't fully understand the logic the first time I read it. So I used AI to really help me refactor and rewrite it. It was much better. So it's really good for that kind of stuff. Obviously great for writing tests, but you still have to review the test and make sure that everything's covered that's supposed to be covered and that kind of stuff. And of course, great for writing OpenRewrite recipes. Now, and one of the things we run into is that a lot of times there's not very good test coverage on these applications, which makes upgrades more difficult, right? So one approach could be writing tests up front, but then you still have to make sure they're good tests. So there still will be a lot of overhead with that, but that is one way to sort of mitigate risks as well. So you can use AI coding system assistance for all this kind of stuff. And as we talked about, you can try doing a loop where it goes and fixes bugs, finds more bugs, fixes more bugs, etc. But at some point, you probably might actually do real software development. So this happens as well. So sometimes there's bugs that you have to fix yourself. And this happens because libraries behave differently than you thought they did or that they're supposed to work, which does happen to us. Different versions cause issues, API changes, and of course, class path issues with Java are always something that pops up. One of the other things you should keep in mind is exposure of existing bugs. Anyone run into this before? So sometimes there'll be some bug that no one noticed, that people will say, "Oh, you created this bug," and you're like, "Oh no, this was there before. You happen to be testing it now." Or my favorite is there's just, and this happens like where there's some hack or workaround that was done with some framework or some API, and then when you upgrade it, that workaround ends up causing a bug because it doesn't work with the new API or something like that. So as an example, let me see, what's a good example? Actually, I can't think of a good example off the top of my head, but like, for example, like if someone swallowed a bug, swallowed an exception, right? Sometimes maybe in the old framework that worked fine, but with the new one that causes a bug. Like you'll end up with weird things like that. So just always keep in mind that's going to be an issue. And if you can do some refactoring, but then again, that depends on the budget and all that kind of stuff. So, and of course, all these sort of things like refactoring and updating look and feel may require actual software development with some help from AI, if you can. Probably the one thing that I think, looking back at the work we've done recently, it's like there are some things that AI may be able to fix, but a lot of it I don't think they could because we're dealing with pretty complicated enterprise systems. Some of them, like there'll be some use case that like is really like hard to reproduce. It's some very specific path that you have to follow. And I don't think AI is quite there yet. I think a lot of the bug fixes you actually have to do yourself. All right. So once you get past the project, it shouldn't be over, right? You got to actually do some postmortem. And actually, I need to do this with one of our clients, actually, so I need to remind myself about that. So one of the things to think about is that you've gotten through the whole process, but what did you uncover, and how are you going to handle it, right? And this has happened a couple of times where we've been like, okay, we found some issue. Obviously, it's not within scope, but how do you handle tech debt like this? What is your process? And sometimes it's just creating a ticket, creating a ticket with the tech debt label. But there should be some way to handle these sort of issues when they pop up. There can be tech debt. There could also be UI UX issues. There could be architectural flaws. So we do like to point these things out because you're spending all this time looking at this application. You might as well benefit from what you've learned, right? So if you've gone through and modernized all this stuff, there may be architectural flaws which can be pointed out. Duplicate code, which is one of our favorites, is something we like to get rid of, but sometimes we don't really have the time, right? So we have to search and replace in 20 places. Search and replace works really well. It's fast, but you should mark these in some ways. And one of the things that we've done, I have another talk on to-dos, which is actually a much more interesting topic than it seems. But what you can do is you can mark all these things as you're going throughout the code with a to-do, right? But you can't do that unless you actually are going to deal with those to-dos before the project's over. You can't just put them there and hope they get dealt with, right? But what we did do in one project is we put to-dos in, number one, for the team to do because we weren't doing all the work ourselves, right? So we're like, to do this thing or do that thing. But also for things that need to be handled. And one of the tasks was to go through and deal with all those to-dos, to either get rid of them or put them in Jira, the issue tracker, or something else. Now, I wasn't the one that had that task, so I didn't get to do it. I hope that it really did get done. But that's the idea, is that there's some way of handling these things, whether it's putting it in a backlog or planning it for another sprint or something like that. And a lot of times the initial modernization, especially the projects we've been in, is not really the end of the road, right? It's like some step. So maybe we migrated or upgraded to the latest versions of everything, but it's still a big monolith. Or maybe we in some cases we upgraded the user interface library, but it's still a server-side rendering library, which is now, I know is now hip again, but let's say they really want to move to React. Well, that's another step, right? So there may be other steps that have to happen later on. And maybe microservices, maybe you want to add some agentic stuff, AI stuff, you want to replace the front end, and then you decide if you want to do it iteratively or big bang. So all starts over again. And the last thing, one of the last things you want to keep in mind is how are you going to avoid this problem in the future, right? So if you're stuck with a monolith or some ancient application that you're still working on, it's still mission critical, but it's really out of date, how can you keep that from happening in the future? And really all it boils down to is build it into the process, right? So there needs to be some process and it needs to be bought in like, pretty high up that we want to avoid this from happening again. But it doesn't have to be a big deal, right? Because once you've done some modernization, you're kind of at a level where it's not a lot of work to maintain it, right? So you can just create tech debt tickets, right? And then add tech debt tickets to each sprint. That's the easy way to do it. But you need to make sure that they're not actually like delayed, right? Because often what will happen is you have a tech debt ticket and then everyone thinks it's not important, so no one does it, right? So you have to actually have buy-in, across the whole team and above it to make sure things actually get done. But that's really all you have to do. And I've seen this work sometimes when there's actually buy-in higher up to make it happen. So, okay. So that's pretty much it. Here are some links. Yeah, that's it. Any questions? And I'd love to hear from anyone else about some of your own stories.
Seems like we're always on the path to modernization. I've been in this industry for more than 2 decades now, and you're always got that one app that needs to be modernized. Man, if you could only modernize on one app, and then it just that list keeps changing and changing, and then you have to figure out which one to do. And it's a huge part of our industry is modernizing, because your top of the line React app from 3 years ago is like, man, that whole thing, man, we like looked at modernize that thing. Things are changing so fast. You have to have fast to modernize.
Yeah, and to me, this really emphasizes like the benefits of different layers, right? Is that you can have some flexibility to move things at different speeds. It's a good thing. But yeah, it changes so quickly. I mean, if you think about all, if you know what I'm talking about, being in the industry for a while, all the stuff that's changed in the industry, and now the way we write code is changing too. So it's just drastically different. I do think though that the fact that we're moving towards AI, writing more of the code, means that we may be able to do more of the stuff faster. Because honestly, some of the stuff, I mean, this is the reason I like OpenRewrite, is because it's deterministic. But if you use it with AI tools, maybe there's more stuff you can do faster. Maybe it's an easier case to make, So if you say, yeah, I need to upgrade these libraries, but I can just run this tool and, spend a little bit of time with some AI, and then magically it'll be upgraded. Maybe that'll help. I don't know.
You need to turn OpenRewrite as a skill for cloud code.
Yes, I'm thinking about that. I'm actually thinking about skills more. How deterministic are skills? Because it seems like that's the idea, but it's still dealing with an LLM, so it still could be inconsistent to some degree.
It just gives abilities to use tools. So you could potentially have AI, not deterministic, pull a tool like OpenRewrite that is deterministic and try to do all the work, even make modifications to it and cause it to have a more deterministic output.
Right. Okay.
Yeah.
Yeah, I thought there was some other level of skills that was more about like the ways that it's supposed to do things, like how you basically saying, okay, whenever you do this, do it in this way. But I could be wrong about that. So, but I imagine there is at least an MCP server for OpenRewrite. I'm sure there's got to be one somewhere. So if there isn't, then I lied, but it seems like there should be. I'll look into it.
If there isn't, there probably will be very soon.
Yeah, I think so. I think so. So, anyone else have any thoughts?
All right. Well, thank you, Kito Man, for showing us all the paths to app modernization. Really appreciate it. I think this is very valuable information, and in our industry, it's critical. It's a critical path that you cannot ignore. So, thank you.
Thank you. Thanks for having me.